Hello everyone, I guess I'm live right now. So today, just to save some bandwidth, I won't be putting turning on the camera. So let me know if my voice is clearly audible. There's not lot of noise, and the stream is smooth. I even changed the network today so that the same thing won't occur today as well. Till then, let me know everything is clear and you can listen to me. Just write yes in the chat section if my voice is clearly audible. Am I audible? Okay, great. My voice is clearly audible, and yeah, so guess we are good to go. Okay, so those. Don't worry about the yesterday's link. Like, if it's the issue, that was the issue from my end. So for yesterday, I'll make sure like everyone's attendance is counted. So even if you miss the last first year attendance, just don't worry about that. Make sure you fill up all the remaining forms and attend all the remaining sessions, and I guess that would be fine. Okay, so till then, let me open the PPT. So we were doing the basis of neural network. I'll try to finish this thing and move on to some next part. We got a bit behind, but that's fine. That's not an issue. We can easily cover that. So yeah, yesterday. So it's already 5:37. So I guess I should start. So I don't know why many of you haven't joined the yet, but don't worry about that. Okay, now let me know one thing. Is my laptop's fan is creating a lot of noise, or is it fine? So it's buffering. Some of you are saying it's buffering. Um, it's showing connection fine over there. It should not be the case. Okay, so let me just put it on silent mode so that it does not create the noise. Is it buffering? The video is buffering, or is it fine? It's showing the connection good over there, and here it's showing the YouTube error. I don't know why. And the speed is, I guess, fine as well. That's not an issue. Okay, it's a bit slow, but the stream should work at this speed as well. Should I change it to okay? If it's okay, do let me know. If it start buffering again, I'll switch the network to this one, and do let me know. Okay, if it start buffering again. So anyway, let's start with the session. So yesterday we were seeing the single neuron, right? So we were seeing. Okay, let me just move to the whiteboard itself. So we were seeing, let's say it's a neuron. It takes, let's say, x1 as input, x2 as input. So I said it gives its output using these three values and three new values. Let's say it's w1, w2, and w0, and it gives the output as x1 w1 plus x2 w2 plus w0. So I was discussing about w1, w2, and w0. What are these? These are actually weights. These things are called weights, and these actually gives assign weightage to each input. So I was giving example of a house. Let's say the first number represents area of the house, and the second number represents number of floors. and I want to predict the price of the house. Okay, let me do one small thing just to make sure. If it start buffering again, I get to know about that as well. To confirm this small thing. Okay, so like let me know in the chat section if the video start buffering again. But if that happens, I'll switch the network. Okay. Like I said, the attendance for yesterday, like don't worry about that. That will be given to all of you. All of you will be marked as present for yesterday's session because it was an issue from my end. Okay. So I was saying these W1, W2, and W0 assigns the weights. So let me give you example of a house. Let's say X1 represent the area of the house and X2 represent the number of floors, and I want to predict the price of the house. So let's look at this data first. Its area, its number of floors, and it's the price. So let's say the area was 5, number of floors were 1, and the price was, let's say, 10. For the second house, the area was 10, the number of floors were 1, and the price was 40. For third house, the area was 5, the number of floors were 2, and the price was 20. Now tell me, if I give you two houses, one is having one area as 2 and number of floors as 1. The second house has area equals to 1 and number of floors equal to 2. Can you tell me which of these two houses will be more expensive? Let's say it's C1. The price of this house is C1 and price of this house is C2. Can you tell me whether C1 equal to C2 or C1 greater than C2 or C1 less than C2? Just write your answer in the chat section. I just predict what will be the price based on this data. Okay, so there's a construction going on nearby. Let me know if it's creating a lot of noise in the stream as well. You might be hearing, like, let me know if there's a noise because of the construction that's going on nearby. Okay, you all got it right. Okay, if it's not a lot of noise, then it's fine. Like that noise is also like irritating me as well. So yeah, so C1 is greater than C2. You see you predicted that yourself, that area has more weightage than the number of floors, right? The area, it has more weightage than the number of floors. Okay, like guys, let me know if there's a lot of noise. I can try to change the mic if it's possible. Okay, or like add few more noise gates. There's a lot of noise. Okay, just give me a minute. I thought so. Like there will be a lot of noise. Okay, I try to avoid noise suppression because it sometimes try to suppress my voice as well. But let me know if if the voice is better and the noise is low. Like there is still a lot of noise. I can hear that noise. Is the noise issue still there? Okay, the issue is still there. Okay, just give me a minute. Let me try switching the microphone. Okay, so the other mic is not working. Like, not even the headphone mic or the podcast mic that I have. Both of these are not working. I don't know why. So I guess we'll have to continue with this itself. Okay, so let me know if I'm audible right now. If you just so guys can just give me a minute, I can go and try the podcast mic again. Okay, if it's audible, like if it's okay, then we can continue. It's totally fine with me. But still, this noise is like, there is a lot of noise at my side because of the construction that is going on. I'm not sure. I have shut the doors and windows and everything, but still the noise is quite loud, and it's still like Shraddha, like if the voice is low, or the issue is something like if the voice is low, then you can try to use headphones or something. Okay, great. If it's fine, then we can continue. So you just saw the parameter area has more weightage than the number of floors, right? So the area is having higher priority than the number of floors in increasing the price. So these W1 and W2 is actually used to give weightage to these inputs x1 and x2. So for area, the value of W1 will be high. As you can see, if this thing increase, this value will in whole will increase and the price will increase. And value of W2 will be smaller compared to W1 as number of floors has less weightage than the area. So these W1 and W2 actually used to give weightage to each of the input value. And this W naught that is actually added, it's something added to just give better results. Like sometimes we missed some factors which might affect the price of the house. Like there might be some other factors apart from x1 and x2 which might affect the price of the house. So just to consider those factors, we consider extra number w naught. If it's not needed, this w naught become close to zero. If this factor is not needed, this value automatically become close to zero. But if it's needed, it's adjust its value. So let me know if W1, W2, and W naught thing is clear to everyone. The basic idea of the basic need of W1, W2, and W naught is clear to everyone. Right? Yes. If it's clear. Okay, great. It's clear to team. Okay, great. So this thing is actually called hypothesis function. Hypothesis function for a neuron. Okay, so this function is called hypothesis function of a neuron. So let me know this equation, like if it's a neuron, it's taking x1, x2, x3 as three inputs. It's taking three value as input. Tell me what will be the value of this hypothesis function? Like what will be this function? Will it be w naught w1 x1 plus w2 x2, or like it will be changed? Write in the chat section the what will be the hypothesis function in that case. Just write that, and I'll be coming in just a minute. You might not hear my voice because I'm muting it for a minute, and I'm seeing what I can do about that noise. I'm just trying to add one more thing to reduce the noise. Okay, so I'm trying to switch the mic and see if this can reduce the noise. I'm trying to use a podcast mic right now. It's better at removing the noise than the other mics. So just give it and see if it can work. Okay, till then let me see if you have it in the answers for that. Okay, so it will be better right now. You won't hear that noise. So yeah, the answer is W naught plus W1 x1 plus W2 x2 plus W3 x3. Yeah, so that's right. You all got that right. So it will be that you have written. So this function right over there is called hypothesis function. That it's the hypothesis made by the neuron. So at the end of the day, our task is to identify these values W0, W1, W2. If we are able to predict the correct values of these variables, then if we are able to predict these values, this function will perform better, right? This will give better results. So it's the second thought that how we can calculate these values. We will see in detail like how we can calculate these values, but our main motto is to calculate these values. Okay. Now moving on to the next part, which is activation function. Voice is low. Okay, let me just remove the suppressor and all. Okay, so I don't think the noise will be low right now. Okay, and if you still think the voice is low, just kind of use headphones or earphones and it will be better. Okay. Now the next thing is activation function. We just saw like we just saw that like if it's a neuron, it calculates h of it's the hypothesis function that is represented by h. Okay, when I'll be saying h, that means hypothesis hypothesis function of neuron. Okay, now but what happens is it was fine. Like we were to predict the price of the house. We saw W1 x1 plus W2 x2 and plus W0. That was fine. It will give me a number, and that can be the price of the house. But what if we are classifying? Like, let's say we have two categories, category 1 and category 2. Let's say it's cat, and the category 2 is dog. We are making a cat versus dog classifier. So in that case, this number doesn't mean me to anything. Like this number doesn't mean anything to me. Like if it's a 5, like it doesn't make sense. If it's 50, it doesn't make any sense whether it's cat or dog. But what I want is I want either 0 or 1, where 0 will represent the class 1. If the output is 0, I can say okay, the output is 0. It means the input belongs to class 1, and if the output is 1, it belongs to class 2, which is dog. Are you able to get this thing? That in the classification problem, the classification problems are one in which we actually given if we give some input, we actually try to classify it, like whether it's from class 1 or class 2. Let's say we are given an image, we need to classify either image as a cat or a dog. So it means we have two classes, one is cat and there is dog. So we need to decide which one it is. Okay, so in such problems we need some labels. We don't need actual number, but we might need some labels, right? And let's see another example. We need some probability from the neural network. We want to get some probability as the output. So probability always. What if there is more, three or more to classify? Yeah, like in that, like we will see what is there. What if there are more than two classes? That's fine. Like don't worry about that. Like I was just giving example, Sanket. Don't worry about that. We will see later on. Like what if there are more classes? But I was saying for the binary classification, the case in which we have two classes, we actually need like 0 or 1, right? And what if we need some probability as the output of the neuron? So probability always lie between 0 and 1, right? So if it's giving the h of x giving me a number, let's say 500, it can't be a probability, right? It cannot be a probability. So we are sure that this thing W0 plus W1 x1 plus W2 x2 cannot be our final answer. This thing cannot be our final output. There is more to it. We need to apply some more operation for this as well. So what we actually do is, let's say this thing was h. We actually pass this h through a function. We again pass it through a function, and this function is called activation function. Let's represent this activation function by g. So this neuron, it takes x1 and x2. It predicts w1 x1 plus w2 x2 plus w0, and then we pass it this value through the activation function, and whatever is the output, that is the final output of the neuron. That is the final output of the neuron. Okay, so let me know if this thing is clear. Please don't worry about that link, that will be shared. The link hasn't been shared yet for today's session, and I mentioned for the yesterday session, the don't worry about the link, you all will get the attendance for that. Just try to focus on this session. Let me know if this idea of using activation function is clear or not, like why we need activation function. Like, it's not that we can always produce our result using this equation. We need something, so we need some more function to pass it through. So in the presentation, I have mentioned a few of activation function. Like I have mentioned like 4 to 5 activation function which are generally used, but actually there are a lot more activation function. Like there are a lot of activation function. I will be just going through these 1, 2, 3 the slide. Okay, if you want, like you can just go to the official documentation of Keras. Keras. I can share the link as well. If you want to go through each different activation function, you can just see it. So first activation function is step function. So what this function do is, it takes the input, the h, like this was the h, right? This thing was h, my input, sorry, output. This take this thing, and if this h is greater than 0, greater than equal to 0, sorry, if this thing is greater than equal to 0, it gives the output 1. And if this value is less than 0, it gives the output 0. Okay, so this thing can give me, this thing can be used for binary classification. If the output of a neuron is a positive number, then this function will give me class 1. And if the output of the neuron is negative number, this function will give me class 0. So that is the step function. So it goes like, if it's 1 if the input is greater than equal to 0, and it's 0 if the input is less than 0. Let me know if this thing is clear to everyone. I mentioned that this thing cannot be our final output, because let's say if we want to calculate probability that lies between 0 and 1, and let's say if we want to if we want to classify between two classes 0 or 1, so this thing will give me a number but not actually 0 and 1. So we need to add something more to it to give me the final output as this or this, like based on our need. So we pass it through a function that is called activation function. So yeah, if it's clear to everyone, then let's create the step function thing. Now the next function is sigmoid function. Mohammed, if you want me to repeat the same thing, this thing, you can just rewind the video a bit, and I have like explained it very like I have explained it. You can just rewind the video a bit, and you can see the explanation. So the next thing is sigmoid function. Okay, so again activation. It's new activation function which goes like this. The equation for this is 1 by 1 plus e to the power minus x. So if this input is equal to 0, it gives me output as 0.5. And if the input is positive number, it gives me a number closer to 1. And if the input is negative, it gives me output closer to 0. So this thing, it means this thing can be used when we need output between 0 and 1, kind of a probability. If we kind of uh, see what is the probability of a person dying in a Titanic accident, in the Titanic incident. So we can use this function. It will be a value always between 1 and 0 based on the input. So the graph goes like this. So this is a sigmoid function. It's a very, it's very popular function, and it's like you will see this thing very much. Like if you just pursue with the deep learning, you will see this function a lot. So let me know if this thing is clear. Then we can move on to the last activation function, the ReLU function. Okay, great. It's clear. Now the next function is ReLU function, and it's, you may say, most commonly used activation function. Like you will see this function is most commonly used. So what it do is it takes the input. If the input is negative, it gives the output as 0. If the input is positive, it just returns that number itself. Okay, if this w0 plus w1 x1 plus w2 x2, it gives me a negative number. Let's say it gives me -5. So this function will give the output as 0. And let's say if they give the number +5, so this function will give me output as 5 itself. So this thing can be used. Let's say if you want to calculate the price of a house, this function can be used, because the price of a house can never be negative. It can't be that I'm buying the house and the owner of the house is giving me money for that. Like at max, it can be, this thing can be 0. The house is free, but it cannot be negative. So it's a ReLU function. What is the probability of a negative output? See, if the output is negative, so this probability will lie less than 0.5. It will be closer to 0. The probability will be less than 0.5, because at 0, it's exactly 0.5, but at less than 0, the probability is less than 0.5. Okay, so at the end, the output of neuron is this one, where G represents our activation function. So it represents our activation function. Now coming to the next part, we will see about OR and I guess tomorrow. Like not this part, like not in the today session. Let me go on to the next part. So okay, it's just the application of neural network that, given some inputs like humidity and air pressure, we can classify whether it's gonna rain or not. So it's a classification problem where we need to give it as 0 or 1. 0 means it's gonna rain, and 1 means it's not gonna rain, right? The second thing can be regression problem, where we need to predict the price. We need to predict a number. The case in which we need to predict a number, that is called regression. The such problems are called regression problem. Like when we need to classify between two or more classes, that is called classification problem. But in case we are actually interested in getting a number, that thing is called regression problem. Okay. Now moving on to the next part. Deep neural networks type of loss. Okay. Now what happens in, like, generally what happens is, we till now we were seeing a single neuron. Okay, but it's not the case. Generally we have a lot of neurons. We have lots of neurons. So what actually happens is, let's say I want to take input. Like let me just give a basic idea of how a neural network looks like. So the neural network contains input layer at first. It contains an input layer. So let's say I want 3 parameters as input. Let's say 3 values as input. So it will contain 3 neurons: first, second, and third. And these are just input neuron. These are not like a neuron which gives some output. These just take the input. These will take three values as input, x1, x2, and x3. And it will pass the output as like x1, x2, and x3 because these are just taking the input. Now at the end, we have output layer. We have output layer. So let's say I want to predict the price of the house. So I can have a single neuron that will give me a number which will be the price of a house, right? But let's just come to the classification problem. What if I want to classify the number between two or more classes? Let's say I want to classify it. Let me change the color to green and the thickness. Now, if it's not a regression problem, let's say I want to classify between three classes. It's not the case of two classes. In the two classes, I can have a single neuron which will either give me 0 or 1 based on which class it belongs to. But let's say I have three classes. In that case, in the output layer, I will have three neurons. I will have three neurons. Where neuron 1, this neuron will represent class 1, this neuron will represent class 2, and this neuron will represent class 3. And each of these will give a number. Let's say this neuron gives a number x1, this neuron gives a number x2, and this number gives x3. Now, these x1, x2, x3 will represent probabilities. These will represent probabilities that if it's 0.2, it's 0.5, and it's 0.3. So these will represent that there are 0.2% chance that the input belongs to class 1. There are 0.5% chance that the input belongs to class 2. And there is 0.3% chance that the input belongs to class 3. So the maximum probability is for class 2, right? It's 0.5. So the output we will predict will be 0.5. So in case we have more than two number of classes, we use this method. And to get these probabilities, like we use the activation function which is called softmax. You can just see that on the Keras documentation. Let me just show that Keras softmax activation function. So the Keras is like you can just, for now you can just take it as official documentation. So you can just go to the activation layers and search softmax over there. You can just read about this from the documentation, like how this number actually calculates the probability. It's quite simple. So I hope you are able to get what we do in the case when we have more than two number of classes. This thing should be clear. Just write yes if it's clear to everyone. Abdul, it's not that like it's Boolean, but if it's just two classes, we can say it can be binary classification like 0 or 1. But in the case of more than one or two classes, we have to use this method of probability. Okay. Saurabh Gill. Saurabh Gill, like if you again write about attendance once more, I will make sure you won't get the certificate. I'll just make sure you don't get the certificate for the bootcamp. Okay, so this thing at the outermost layer is output layer, and the first layer is input layer, right? Now in between these layers, I have a lot of layers. I can have a lot of layers, and these are called hidden layers. These are called hidden layers of the neural network. So I can have layer 1, and in this layer I can specify, like for each layer, let's say it's layer 1, hidden layer 1, it's hidden layer 2, it's hidden layer 3, and for each different layer I can specify how many number of neurons I want in this layer. So I can specify in the hidden layer 1 I need 5 neurons, and in hidden layer 2 I want 3 neurons, and in hidden layer 3 I want 4 neurons. So I can specify the number of hidden layers I want, and the number of neurons in each layer. We will see how we actually how code this thing. Don't worry about that. But these layers are called hidden layers, and more the number of hidden layer we have. Let's say we have 10 hidden layers. So the more the as the number of layer increase, we say the neural network is deeper. So more the number of hidden layer, the deeper the neural network is called. Okay. So that's actually a deep neural network look like. Let me show you the whole thing that we just covered. We have covered uh, with the small, animation that I had made. A small animation I made and posted on Instagram. Let me just let you guys go through that thing. So you will have a clear picture of what we have discussed till now. So we have this thing on our Instagram page. Let me just show that thing once. It was a video actually. With that animation, it will become like quite clear. If you have any doubts, though, that thing will clarify everything. Like till then, let me know if you guys have any doubt. Like it's not that you can also say like the name is deep learning, but it's not that you should have more than one hidden layer. You can have a just single hidden layer as well. That's not an issue, but at least you need a hidden layer because output layer will give you just output, and the input layer will give you input, right? But sometimes like we do have like um, yeah, like we should have at least one hidden layer. Let me see if it's a video. Just give me a minute. It's taking a lot of file. No, it's not the one to load. Don't know why it's taking quite a while. It's not the one. Okay, fine. Like, let it be like let's just give it some time to load. I don't know why it's quite slow. Maybe because the stream that is going on. But I guess this thing should be clear to everyone. The thing that we have discussed till now. Sanket, that's not normally the case. It's not like generally don't get stuck when two probabilities are same. It's not the case normally that you don't have two probabilities as same. Like you never get into such situation. Like practically don't, but it might be a case one out of a like 1 lakh. In that case, you can choose any class that you want. Ambuj, that thing is completely random. It's not that we know beforehand that how many number of neurons and how many hidden layers we need. It's just that we train a neural network, we see its performance, and if it's not doing very well, we try to change the number of hidden layers and neurons. So it's completely random. No one can predict that how many neurons and anything we need for that. So it's completely random. Like, but see, like, okay, here's the video. But it's that like once you start training your neural networks, you will get a basic idea of what neural network like this whether this neural network will perform good or not, and you will be able to predict based on the performance of the neural network whether you should increase the layers or you should decrease the layers. Okay, so let me just show you this video. So see, it's an input layer. It's taking the inputs x1, x2, and x3, and we have the hidden layer one, which is having two two neurons. So each of the neuron take input from the these input layer x1, x2, x3, and it's also taking x1, x2, x3. And for each connection there is a weight, this separate weight, w11, w21, w22, w31, like there's separate weight. So each input gets multiplied by the weight and they reaches the neuron. So they get the input x1 w1, x2 w2, x3 w3, and they different weights for this and different input. So inside the neuron, when it get this thing, it add all of these. But here, like, we have missed w naught, the extra term, but just forget about that for right now. For now, like, that thing is added, but just consider that thing is over there. So those things are added, and then the output that we get is passed through activation function applied, and then we get the output of the neuron. So both of these neurons generate O1 and O2 as their respective outputs, and these outputs are passed on for the next neuron in the hidden layer, next neuron in the next layer, and again it takes that and multiply it by its weights, and based on that it produces its output, and we get the output through the output layer. Like, there will be output layer here, and we get the output through that neuron. So that is basically how a neural network works. So I guess this thing should be clear to everyone right now. Does the number of neurons in a layer depend on the number of neurons in other layers? No, it's not that. It's just complete. Like, in the one layer you can have 10 neurons, and in second layer you can have, let's say, 1000 neurons. So it doesn't matter. It's totally up to you how many neurons you want. Okay, great. If it's clear, then we can move on to the next part, which is loss function. Like, it will be the last thing for today's session. Now, like, this thing is basically related to no, like, the activation function. You may say, like, the input layer is taking input, right? So it doesn't need any function. It does not need to produce any output. It will just take the input and pass it on. So that doesn't need any activation function. And the last layer need activation function to give the final output. So that is needed over there. Activation function is needed by hidden layers and the output layer as well. So, like, generally the last hidden layer, which is giving me the output, is called output layer. But we can also say, like, that's called output layer, where it's giving me the final output. So output layer also have activation function. It's not that the activation function is needed by the hidden layer only. Okay, so now see about getting values of W0 and W1 and W2. So what happens is, just understand by a single neuron. Let's say it's a neuron x1 w1, x2 w2, and it produces w0, and it produces output, let's say o1. After applying activation and all, it produces output o1. Now, while training to this neural network, we give the input x1, x2, and we also give the corresponding output. We give the actual output for this x1 and x2 was y1. Okay. Now what we do is, we actually, using o1 and y1, we calculate a loss. Using these two values, we calculate a loss, or we may say we calculate error. We will see what kind of loss function, error function we can use. But we use some function to calculate some error or loss. So let's say error comes out to be e. Then we pass this error in backward direction. We say, okay, we go to this thing and we say, okay, the error was this one. Now adjust yourself based on this w1. Adjust the value of w1 such that this error value decreases. We pass this error to this w2 as well. We say, okay, the error was this one. Now adjust the value of w2 such that this error decreases. We again pass this error to w0 as well. We say the error is this one. Adjust value of w0 such that the error decreases. And we adjust value of w1 a bit, like we just decrease the value a bit, and W2 and W0, like we adjust these values, and then we give the next input. Let's say uh, x11, x12, let it was x11, x21, and x22. We give the second input and corresponding y2 for that. Now, based on this new w1, new w2 and new w0, it produces output o2. We again calculate the error. We again pass it. Okay, now this time the error was this one. Now adjust this new w1 such that this error decreases. We keep on doing this process till we start getting good results. We keep on adjusting these w1, w2, and w0 till we get the good results. Okay, you're asking me to unplug the charger. Like that's fine. Like it's a gaming laptop, so it's habitual of getting plugged in all the time. So it's not an issue. So let me know if this thing is clear to everyone. The way we update the weights, like the actual function, like the basic idea of how we make the changes, like actual function, like actual way of updating these weights, W0, W1, and W2. That is like that contains a lot of derivatives. If you guys are like you all are like aware of derivatives, like taking derivation, we can go in that as well, like how these weights are actually updated. But if you are not comfortable with derivatives, we can skip that part. Like obviously we'll doing that in tomorrow session if we will go into that. But let me know, are you aware with derivatives and all? Like, do you want to actually see how these weights are updated, or the basic idea is fine? You are aware of derivatives, that's great. Like Rajesh is, like those who are not like aware of that, like what are derivatives, how we calculate derivatives. For those, you can just go on YouTube, like, and yeah, like the basic idea is fine. You should know what is dx square by dx. That's fine. Like we won't be doing derivatives, but I like I'm not saying you should know how to calculate derivatives, but you should know what derivatives actually mean. Like you should know what derivative mean. I'm not saying you should know how to calculate derivatives, but you should know if I'm doing dx square by dx, what this actually represents. Like it represents the slope of tangent, right? Namira, like we train deep neural networks to actually like self-driving cars, your Google Translator, like all those things are run by deep neural networks. It has a lot of application. If you go into the PPT, on the first slide you will see its application. On the first slide itself, you will see the application of deep neural networks. Like these are just a few application, but deep learning is actually a part of machine learning. So it contains a lot of application. Like deep learning is kind of one of the most powerful algorithms of machine learning. So all these things like are the application of this one. We will see, like while doing the project, we will see an example of how we can use neural networks to actually do something useful. Okay, and one thing, you have the access to the PPT. Make sure you go to these three pages: this OR function and function. Like it's quite simple. You will get like what is happening over there, and there's a small issue in this PPT. It's OR, so it should be 0 0 0 over there. And it 1 1, it should be 1 over there, right? So it's actually we're trying to see what if we're trying to implement an OR gate, we are seeing what can be value of W1, W2, and W notes that this thing acts as a OR gate. Okay, like just try to see through this once. I hope you will be able to understand it. So now coming to the error function, to like when let's say like when we have the neural network, it predicts output O1. and the actual output was y1. So here y represents the actual output, like y, and y dash represents the output predicted by the neural network. Predicted by the network. Okay, so we can use residual loss, like just subtract this thing, but this function is not good to calculate error, because let's say, because this thing, we try to decrease the error, we tends to decrease the error. So if we use this function, if the error is negative, let's say the actual output was 5 and we are predicting 10, so the results are wrong. 5, this output is wrong, it is having -5 error. But if we are trying to decrease the error, it will say, okay, -5 is less than 0. It will try to decrease it further and it will increase output to 11 or 12. So this function to calculate error, we should avoid this thing. So we can use squared loss function, or we can use absolute loss function. So squared loss works better. Like if the output was 10 and 5, so 5 minus 10 square, that is 25. It's a positive number, and 5 minus 10 modulus gives 5. So squared function does a bit better job than absolute function, because it gives the more error. If the output is if the difference is large, it gives me a more error. It will say, okay, you have created this much error, now adjust yourself. So let me know if this thing is clear to everyone. Basics of losses. There are a lot of complex loss function. Like these are the simplest loss function that I chose for this PPT, but there are a lot of complex loss function that we actually use. But it's just to give you a basic idea. Dhanushi, like this thing, the topic that I mentioned that contains derivative, that is actually important. Like that thing is called back propagation. That thing is called back propagation. But in the bootcamps, I generally try to like avoid going through this thing because it contains the derivatives. And if we, just go into that, most of you like are not like most of the students are not able to get that thing. So I thought like this time, why not just go into that as well. Rajesh, it's not good because let's say we are using the residual loss. Our task is to decrease the loss, right? We try to decrease the loss. Okay, it's not working. Why is that? I don't know why. Oh, certification is free. Don't worry about that. For this thing, certification is free, and I request you all to subscribe the channel or like the video. At least like the video. Like that will give me a good confidence that I'm teaching very good. So that just increase my morale. And I have changed the setting. Like I just checked, the setting was that only the subscribers can send the message. So I changed that as well. So if you like if you like the bootcamp, just make sure to subscribe that. It's actually not compulsory for this attendance, for the certification and all. But it's just that if you want, like, make sure you do that. Okay, and for the residual loss, one of you was asking why it's not good. Let's say the actual output was 5 and the model predicted 10. And let's say another model predicted 50 and actual output was 5. It was model 1. It was model 2. So clearly model 1 is doing better than model 2. It's not doing very good, but it's better than model 2, right? But if I'm using actual residual loss, it's 5 minus 10, which is minus 5. And it's 5 minus 50, which is minus 45. So this is giving more loss or more error compared to this one. And sometimes like what happens is, let's say when instead of doing one error, sometimes we take more than two inputs. Let's say we take two inputs and we calculate average error of that, and then we pass onto the neural network. Okay, the average error for the two cases was this one. Now adjust your weights that this error decrease. So what might happen is that y minus y dash, one time it can give you a negative value, and y minus y dash other time can give you a positive value. So if you calculate the average, they cancel out each other and the loss becomes zero. So it says, okay, I'm doing very good. Like for the one case, it predicts for the 5, it predicts the output as 10. And for the next case, for which the output was 10, it predicts 5. So it's more or less not doing well, but the average error for this one will be zero if you're using residual loss. So that's why it's not good to use residual loss. Like don't worry about that. Like we will tomorrow. I'll try if time permits. Like after we see the back propagation, if time permits, I will try to go through a small neural network while training a small neural network. Like if not tomorrow, we will try to train a small neural network a day after tomorrow as well. Like if we are not able to train it tomorrow, we will try to train it day after tomorrow on the day 4. Okay, great, Rajesh. So like we will keep this thing up to here till now. For today's, it will be up to types of losses itself. And tomorrow, if you guys want, we can go with back propagation, like actually updating the way of actually updating the weights. Just make sure before to attending tomorrow's session, you have a bit knowledge of like what actually this derivative represents. Just make sure you have basic knowledge of what derivative represents. Derivative represents. Like let's say it's a curve. So derivative at this point will give me negative of slope of tangent, right? If it's a point. So for this point, this blue line is a tangent and its slope is positive. So the derivative value will be negative, right? Sorry, it will be positive. It gives me slope of tangent. Derivative gives me slope of tangent. So this is tangent and its slope is positive. So derivative will give me a positive number. Just make sure you understand this concept tomorrow, and like that's all you need to know. Okay, and let me share the attendance link as well. Okay, issues. Page becomes unresponsive. Okay, am I audible? Just write yes if I'm audible. Actually, the page became unresponsive. The YouTube page that I'm having, that became unresponsive, and was not able to just refresh the page. Let me know if I'm clearly audible and everything is fine. Hello. Yeah, like if I'm audible, that's great. Just give me a minute. Let me switch on to the ShapeAI account. It's not the one, I guess. No, it's the one. So yeah, and don't worry about the day one attendance. That will be like everyone will be marked as present for that. So yeah, I can understand you. I've just got 99 responses. That's because there was an issue from my end. Let me just make it day two computer vision and CNN. Yes, spelling is a bit wrong, but that's fine. Vision and so it's day two actually, and I guess that's fine. It should accept the response. Okay, so here's the link for the same. Like I had to share the link in the chat section for some reasons yesterday, but like there are some constraints that we cannot share the link in the chat. That's not allowed. So I'll be showing the link. Okay, just pause the video, take a screenshot, and just copy this link in the browser. Okay, and paste it to fill the attendance. One thing I would like to tell you guys. Okay, that's the attendance link is working fine. Okay. Now one thing, if you're pasting this link, let's say it was capital Q. If you enter small q, in that case, if you're like making some mistake in the spelling, you will get this error: dynamic link not found, Firebase. If you're getting such error, it means you have entered the wrong spelling. Make sure you enter the correct spelling for the link, and make sure you fill up the attendance form. The link is working perfectly fine, and it will be responsive for like before tomorrow session. Up till tomorrow session, the link will be responsive. After that, the link will be closed. So I guess if you guys have any doubt, let me know. Else I'll end the stream. Sachin, you can just rewind the video if you want the link again. It's a YouTube video, so you can just rewind it, and you will get the link. But anyways, let me show it once again. If you need that. So like this time the link might be different, but don't worry. Like every time I refresh it, they get a new link, but all the links they redirect to the same page, so that's not an issue. Okay, so I guess yeah. If you want, you can leave. So that's it for today, and I hope to see all of you tomorrow as well. And I hope, like, make sure one thing, just make sure you understand what is the purpose of derivatives. you understand like what actually derivatives helps us to find out. Okay, so yeah, that is it, and I hope to see all of you tomorrow as well.